Hi folks, this is Williams. Today's topic for this video is discontinuities on graphs. We are going to talk about the different types of discontinuities. We're not going to talk about the definition of when something is not continuous. That is something that is in calculus, but we are going to talk about the types when we're looking at graphs. Make sure you have your notes pulled up from Google Classroom. So right here we have an asymptote. An asymptote is a line that the graph approaches but never reaches. So for vertical asymptotes, the ones that are going straight up and down, those are discontinuities. You know that it's an asymptote because the y value approaches infinity or negative infinity on either side of that vertical asymptote. So if we're going from right to left, then as we get close to that asymptote, the graph goes up toward infinity. If we're going from left to right, as we're going close to -3 to that asymptote, the graph goes closer to negative infinity. It approaches negative infinity. That is a vertical asymptote. Every once in a while you'll have a calculator that, because it's old, will effectively show the asymptotes, the vertical asymptotes, but most will not. You just have to know that they're there, and we won't talk about where they are right now. That is in about a month and a half to 2 months when we'll talk about finding where they are. At this point, you just need to be able to tell when you look at a graph, hey, that's an asymptote. An asymptote will be marked by a dotted line. There are horizontal asymptotes and diagonal or oblique asymptotes, but those are not discontinuities, so we're not talking about them right now. That'll come up in a couple of months. Then we have removable discontinuities. A removable discontinuity is a hole in the graph marked by a circle where no output exists for that input. Calculators will not show these. They will give you an error if you're calculating it, but they will not actually show the hole in your graphing, and you have to graph that hole yourself by marking a circle on top of that point. So right here, there's a removable discontinuity at an x value of -3. That y value is just about at +3. And if any of you ever go into calculus, you'll learn how to calculate exactly where those removable discontinuities are. The last type of discontinuity is a jump discontinuity. It's a hole in the graph where the graph jumps to a different y value. It only exists in piecewise functions. So the piecewise functions that we've been discussing lately, where we've been doing domain, we've been doing limits from graphs, we have been graphing them. This is the only time that you'll see a jump discontinuity. The yellow calculators that you're used to, the TI ones, cannot graph piecewise functions, so it won't show them. Desmos can graph piecewise functions, but it won't show open dots versus closed dots unless you really know what you're doing really well. So this is a jump discontinuity. It jumps from this open circle to this closed circle. And this is a jump discontinuity. It jumps from this open circle to this closed circle. And we've seen some, like I said, we've seen some like that on graphing piecewise functions that we did recently. If you have any questions, email me. Until next time, be well, do good.